In this tutorial, we are going to create a more advanced version of the domino we created earlier. Unlike the simple version, this one fully supports motion blur, so it is ready to be rendered and used in a video. But it also has a couple of other new features. The first one is that we now have control over the speed of the fall, allowing us to get the extreme slow motion. When set at 1, it has the same speed as the simple domino. One new brick starts to fall every frame. If we decrease it, it falls slower. The other big difference is what the line looks like when we change the shape. In the simple version, the bricks themselves bend to follow the curve, getting distorted. But now in the new version, the bricks keep their shape at all times. In a sharp curve, you can see how the bricks spreads out when they fall, making it look much more realistic. So, that's it. Let's get started. For this advanced version, we are going to use the simple version we created earlier as a base to save some time. Most of it already works, so there's no need to do everything from scratch. Let's start by activating all the viewport selection and visibility we deactivated before. Let's also set the pivot point back to median. The main issue with the simple domino is the section of falling bricks. The bricks are not actually falling, so that stops us from both getting working motion blur and changing the speed. So we will have to replace it with another solution. Now, before we jump right into creating this new solution, I would like to give a quick overview of what we are going to do beforehand, so it is easier for you to understand what is happening. The first step will be to give a single brick a falling motion by adding a driver to the rotation and adjusting the curve. When that brick looks like we want, we will duplicate the brick so we get 6 of them, just like the static piece we had before. When that is done, we need the bricks to move forward so the entire falling part moves along the line. This will be done by always moving the brick last in the line to the front again, as a repeating cycle, making it move ahead. However, one of the main reasons we are doing an advanced version of the domino is because we want it to work with native motion blur. Making a piece jump from the end to the front would give the brick motion blur even though it is standing still in the eyes of the viewer. This can be avoided by making sure that the brick is hidden before it is moved. To do this, we will need to add an extra 7th brick. That way, one brick can always be hidden, moving to the front of the line without getting noticed. And when it becomes visible again, the brick now last in line will get hidden, making sure there's always just 6 bricks visible. So, now you know the core idea behind how the new falling section will work, so let's get started. The old falling section will obviously be replaced, but we won't delete it right away. The falling motion it has, even though it is just an illusion, is still correct. So instead of trying to find that motion again, we can reference it when we create a new version. We will start by just making one brick of domino fall correctly before we duplicate it to create the rest. First, I will add some space in the center of the scene for this new brick by moving the entire line of the domino 1 unit to the right. A good way to do this is to add a shape key to the curve. That way we can change the curve any way we want and still be able to go back to the original shape. Now we have room to add a new brick in the beginning. To save some time, just copy the standing line and rename it falling brick. Delete all drivers, modifiers, and reset its location so it is moved to the center. Now I would like to give this new brick a falling motion by driving its rotation. But instead of rotating the brick directly, I will add an armature and drive the rotation of a bone controlling the brick. This will make things more organized, collecting all the drivers inside one armature. Add an armature, name it falling motion, and give it a B-bone display style. This default bone will control the brick. We don't want the bone to overlap with the brick, so give the tail a location of -1, moving the entire bone below, while keeping the point of rotation at the bottom of the brick. Finally parent the brick to the bone. And now if I rotate the bone, the brick is falling. To make the brick fall by itself, I will add a driver to the rotation of the bone. It is currently using the difficult quaternion rotation mode, so switch to XYZ Euler. add a driver to the Z rotation. The entire falling motion will be done by adjusting the curve, so just give it the simple expression frame so it moves along the curve 1 unit per frame. Now we are going to reference the old falling section. I can easily capture the falling motion from it by making the new brick lean on the old bricks as the animation is played. Much like when we made the spider walk, we will go through the falling frame by frame and adjust the curve so it fits. Currently, the first 2 bricks starts to fall at the same time. Since the line now has an extra brick in the beginning, I would like the old bricks to start falling 1 frame later to leave room for it. So set the start frame to 1. And now 1 new brick starts to fall on every frame. Currently the new brick is not rotating correctly, so let's go through frame by frame, starting at 0 and adjust its curve. In the beginning of frame 0, the brick should be standing straight, so keep the keyframe at 0. On frame 1, the brick has started to fall, so it should be leaning on the brick in front of it. Adjust the second keyframe to fix this. Move on to the next frame, duplicate the last keyframe, and make sure the new brick still leans on the brick in front of it. Repeat this until frame 6. We don't need to do it for any longer, since after that, the brick will be replaced with the section of fallen bricks. To make the transition to the static fallen brick seamless, make sure that the final rotation of the falling brick is 74 degrees, the same angle the fallen bricks has. This can easily be done by writing the key value 74 directly. As you can see, we get a fair amount of intersection. This is because 6 bricks is quite few to transition from standing up to the final angle, and therefore you need to force a much bigger change than can actually fit. But I think it looks okay. And now we have captured the falling motion in a curve. However, we don't want the brick to continue rotating after the keyframes we created, so set the extrapolation mode to constant. And now the brick just goes from standing to lying down without moving any further. Great. Now when we have successfully captured the falling motion from the old falling section, we can move the new brick to its own layer so it is easier to focus. Move both the armature and the brick itself. This brick has a basic falling motion right now, but there are still a couple of things we need to change before it is ready to be duplicated to create the rest of the bricks. As I demonstrated earlier, this brick will move ahead in the line again after it has fallen, so we need the falling motion to repeat, instead of just ending completely. We can do this by adding a cycles modifier to the curve. We want the brick to stand still until it falls for the first time, so set the before setting to no cycles. And now it won't move until the first fall, and then it will continue to fall over and over again afterwards. As I told you earlier, we will need 7 bricks. This means that if 1 new brick is supposed to start falling every frame, the bricks should fall every 7th frame. Currently, this brick falls again every 6th frame, starting over at 6, 12, 18, etc. So we need to make this cycle 1 unit longer. We want the actual falling motion to remain as 6 units long, since that is how long the brick will be visible. We just need to add an extra unit, happening during the time the brick is hidden. Since the brick won't be visible, nothing special will be happening. I will just make the brick stand still for 1 unit before it starts to fall again. While I add this 1 unit of standing still, I need to pay attention to where the transition between lying down and standing up again is placed. To make sure that no motion blur from the transition becomes visible, I want this change to happen right in the middle of the hidden period. That is, right between frame 6 and 7 at frame 6.5. To add 1 unit of standing still while keeping the transition in the middle, we can just add a half unit in the beginning and the end of the curve. Let me show you what I mean. First turn off the auto snapping, otherwise we can't place keyframes at half frames. Duplicate the first keyframe and move it 0.5 units earlier. That increases the length of the cycle by 0.5 units. Then duplicate the last keyframe and move it 0.5 units later. Now the entire cycle takes 7 units, or 1 unit more. And the actual transition between fallen and standing happens right in the middle of frame 6 and 7. Now this curve has been adjusted to work together with 6 other bricks. All that is left to do before this brick is completely done is to replace this frame expression. We want this driver to use the same as the rest of the domino, the current time property. The driver gets a value of -1 even though we are on frame 0. This is because we gave the domino a start frame of 1, so just go back to the first layer and set the start frame back to 0. And now the brick starts to fall on frame 0 like before. Great. We now have one brick that falls like we want, so it is time to duplicate it to create a total of 7 bricks. I will quickly rearrange the windows by removing the 3D view and adding it on top of the driver window instead, so I get more horizontal space. This way I will be able to see more of the line of domino, since it will become a very wide shape when we start adding more bricks. With that done, copy the falling bricks 6 times using linked copies, since the bricks should always remain identical, and place them 1 unit from each other. Select the armature and duplicate the only bone 6 times as well. Then parent each brick to their corresponding bone. Now all the bricks fall when I rotate their bones. To make this falling happen automatically for these new bones as well, we just need to copy the rotation driver from the first bone and paste it to the rest. Since the drivers are currently identical, all of the bricks fall at the same time when we play the animation, which is obviously not correct. Each brick should start falling 1 frame later than the previous one, so we need to offset their curves. The second brick should start falling 1 frame after the first one, so select its bone and move the curve 1 unit along X. The third brick should start falling 2 frames after, so move the curve 2 units. The fourth brick should start 3 frames after, so move it 3 units. The fifth brick 4 units, the sixth brick 5 units, and the seventh brick 6 units. And without having to do anything else, it looks like the bricks are interacting with each other, giving us a falling motion sweeping from left to right. Thanks to the curve being flat before the first fall, they all stand straight in the beginning, starting to fall 1 by 1. And thanks to the cycles modifier, they continue to fall over and over again after. This repeated falling currently looks a bit weird, but that is only because the bricks are staying in the same location. After a brick has fallen, it should be moved to the front of the line before it falls again. To do this, we will drive the location of the bones. Let's start by adding a driver to the X location of the first bone. Hide the rotation driver so it's not in the way, and set the new location driver to use the current time property like the other drivers, so they are all in sync. The curve won't need any smooth movements since the brick will be hidden when it is moved, so change the keys to constant. Just like with the rotation driver, I want the transition to happen right between frame 6 and 7, the hidden period, to avoid any motion blur. So move the second keyframe to frame 6.5. This is where I want the brick to be moved to the front of the line. Since there are 7 bricks, it needs to be moved 7 units to reach the front, so give the key a value of 7. And now the brick is moved to the front of the line at the same time as it stands up again. The driver currently has a cycle of 6.5 units since the first and last keyframes are 6.5 frames apart. The cycle has to be 7 units long like the other drivers for it all to stay in sync, so duplicate the last keyframe and move it a half unit later, to frame 7. Just like with the rotation, we want this movement to repeat forever, so add a cycles modifier. Set the before setting to no cycles so nothing happens before the first fall. Since we want the brick to move further and further away with each fall and not pulse in the same location, we will set the after setting to use repeat with offset. Now the curve keeps climbing higher and higher, making the brick move further and further away. And as you can see, each time the brick has fallen, it is moved 7 units ahead. To make every brick in the section move like this, we just need to add the same location driver to the rest of the bones. Copy the driver and paste it to all of them. Since each brick falls 1 frame later than the other, we need to offset the driver by 1 unit for each brick here as well. Hide the rotation drivers so they are not in the way. Select the entire curve and move it 1 unit later. Two units. 3, 4, 5, and 6. And now the entire falling section continues to move ahead forever. It looks like the falling section is working perfectly right now, but we still have one thing left to do. We added 7 bricks instead of 6 so we could hide the one that is currently moving to avoid motion blur, but currently all 7 of them are visible at all times. So we need to hide each brick whenever it is moving to the front of the line again. This can easily be done by adding mask modifiers to the bricks and driving their visibility. Let's start with the first brick. Add a mask modifier and add a driver to the selection toggle. Set it to use the current time like the other drivers. Since we are driving a toggle and the output will always just be either on or off, we won't benefit from any smooth curves, so set the keys to constant. We want the toggle to be activated all the time except for in the transition between fallen and standing, which happens between frame 6 and 7. So give the entire curve a value of 1 except for between frame 6 and 7. There it should be less, deactivating the toggle and hiding the brick. We want this to repeat every 7th frame like the other drivers, hiding the brick every time it is moved to the front, so add a cycles modifier to it, with no cycles in the beginning. Now we just need to add the same hiding functionality to the rest of the bricks. Start by adding mask modifiers to them, by selecting all, with the first one last, and link modifiers. Then we can copy and paste the toggle driver from the first brick. Like with the other drivers, we need to offset the curve 1 unit for each brick, since they each fall 1 frame later. Move the entire curve 1 unit, 2 units, 3, 4, 5, and 6. And now the bricks are hiding like they should, showing only 6 bricks once it starts moving, hiding the brick that transitions from fallen to standing again. Great! We now have a falling section that is working great, so let's try to combine it with the old line of Domino. First of all, we need to prepare the old part a bit, so go to the first layer. The old falling section won't be needed anymore since we have a new one, so we can delete it. Remember to delete the pieces used for the ending animation as well. Also move the curve back to the center by removing the shape key. With that done, we can activate both the first and second layer to see how the two combine. Since both of them are already driven by the same property, current time, we won't have to do anything to keep them in sync time-wise. However, when we move along the timeline, we can see a problem with the fallen bricks. They are constantly one brick after, so we need to increase their count by 1 to close the gap. The count is decided by this time -6 part. Change it to -5 to increase the value by 1, and now the gap disappeared. You need to change from -6 to -5 in the mask driver as well, so the first brick shows up when it should. And now the fallen bricks are working great. The standing bricks need some fixing as well. For the old falling section, the bricks entered one by one, but for this new one we have 7 visible bricks from the start. This makes the standing section overlap with the falling section in the beginning. To stop this, we need to decrease the maximum value the driver can have by 7. So change the maximum part from length to length -7, and the line of standing bricks won't reach any further than to the falling section. Since we now have a new, much improved falling section, we are ready to add a bit of functionality to the line itself. I would like to add a speed control so the user can choose how fast the bricks are falling. Add a speed property to the curve and set the minimum value to -1. This will give us the ability to make the curve fall in reverse, making it stand up again. Then add that speed as a variable in the current time driver so we can affect how fast the time goes, and therefore how fast it falls. Multiply the entire expression by speed. And now we can give the line a speed of say 0.1, making the domino fall much slower. And since every part of the domino is driven by the current time, it works right away. Now for the first time, we can see a real difference between the old and the new falling section, showing us how the bricks are actually falling using the curve in the drivers. Now when we see the falling of the bricks with much greater detail, we can investigate another problem. Let's hide the fallen bricks so we can focus on how the falling section and the standing bricks are syncing. Whenever the falling section moves a brick to the front again, the standing bricks should decrease by 1 to make room for it. However, right when the brick appears at the front, the standing brick still has the same count, making the two overlap. On the next frame, the number of standing bricks are decreased by 1, and the problem disappears. So why is this happening? Why are the two overlapping right on the frame where the brick is moved to the front? It is because the falling section moves a new brick to the front whenever the current time reaches a whole number. So whenever the current time reaches a whole number, the count in the standing bricks should be decreased by 1. This is currently not happening because that count expression is length minus time. When the current time is exactly 10, the count driver becomes exactly 16, showing 16 bricks, which is too many. Then one frame after, the driver value becomes less than 16, resulting in a count of 15 since the decimals are just removed without any rounding, and the problem disappears. So how can we make the standing brick flip to a lower count right on the frame where the current time reaches a whole number? By simply giving the driver a slightly lower value, pushing it below the threshold. If I subtract 0.001 from the count driver, the driver value becomes 15.999 when the current time reaches the whole number, and therefore the count is decreased to 15. And now the count of the standing bricks are decreased by 1 exactly at the same time as the falling section moves 1 brick ahead, avoiding any overlapping. Unhide the fallen bricks, and now the entire fall except the ending is working. Great. Before we move on to fix the ending, I would like to improve how the bricks are following the curve. First of all, we need to add a curve modifier to all of our new bricks so they follow the curve at all. We can add it to the first brick, and then simply link the modifiers again. This won't affect the unique drivers we have given to each brick's modifiers. And now they follow the curve like the other bricks. However, currently the bricks themselves are getting bent by the curve, not keeping their shape. This is something I would like to get rid of by changing the way I display them. To make the bricks follow the curve while not distorting their shape, I will use something called duplifaces, short for duplication faces. What duplifaces does is replicating an object on every face of another object. Let's say we have a simple sphere and a single domino brick. Using duplifaces, I can make this single brick appear on every face of the sphere. To do this, we first need to activate duplication faces on the sphere. Nothing happens, and that is because the sphere doesn't have any children. It is the children that gets duplicated by this option, so parent the brick to the sphere. Now suddenly a large group of bricks appears in the shape of a sphere. However, they are not on the surface of the sphere. The location of the bricks is decided by the location of the child brick, so having it here on the side moves them all to the side. If we move the brick to the same location as the sphere, the center of the scene, the replicated bricks lines up with the sphere, making one brick appear on each face. This is how we will create our entire domino, by placing faces where we want bricks to appear and then add the bricks using duplifaces. That way, the bricks will always keep their shape no matter what we do, since the brick shape is contained untouched in the child object. Before we get started, I would like to move the line of domino out of the way using a curve shape key so we get some more space around the armature. Add a shape key and move the curve 3 units up. So, what we will need to do in our line of domino is to replace every brick with a single face and then add bricks to those faces using duplifaces instead. I will start with the fallen section, so move along the timeline until it becomes visible. Let's start by adding the child object, the brick that will be added to the faces. This child object needs to have the same shape as the fallen brick section currently has. We could duplicate the entire fallen bricks object, but then there are several things we would have to remove if we want the object to be like new, like the drivers and modifiers. So instead, I will just add the same mesh data to a new object. Before we add the new object, remember that the location of the child is very important. For the replicated objects to line up with the faces, the child needs to have the same location as the parent, which in this case is the fallen bricks. The fallen bricks has a location of 0, 0, 0 in the world, so make sure the 3D cursor is right in the center. Add any type of mesh, it doesn't matter since the shape will be replaced either way, and name it dupli fallen. I will name all of these brick child objects dupli in the beginning so we can easily see which they are. Shift select the fallen brick and link object data. Now it gets the same shape as the fallen bricks, and in the object data panel, we can see that they share the same mesh data, since this 2 tells us the data has 2 users. Let's rename the mesh data fallen brick so we can keep track of our different shapes. We now have a complete child object, the object we will replicate. With the original fallen object selected, make the mesh data single user so we can modify the shape without affecting the child object. Enter edit mode. Since duplifaces works by adding one object per face, we need to replace this single brick with a single face. So remove the entire brick and add a plane instead, and scale it down to something small so it doesn't cover as much of the viewport. The size of the face won't affect the duplication anyway. Finally rename the mesh data single face so we can easily select the same shape for other objects later. We now have the parent, a series of faces deciding where the bricks should be, and the child, the brick itself. So now it is just a matter of activating the duplication. With the fallen section selected, activate duplication, faces. And then parent a single brick to it. Now a brick is added to every face, giving us the same line of bricks as we had before, but with the big difference that the bricks won't get distorted. The curve modifier will just change the shape and location of these single faces. And as you can see, when I change the curve, their shape remains. Great. As you can see, the child object we used to create the bricks is still visible here in the viewport. This is why I moved the curve upwards to give us some more space. If I kept the curve in the original location, we would get multiple bricks in the same location overlapping, making things hard to see. Don't worry though, this brick used for duplication won't be visible when we render, it is just visible here in the viewport. To know what the rendered result will look like, just focus solely on the line of bricks above. Everything else, including the single faces the bricks are added to, will be invisible when we render. Now the fallen bricks are working, so let's do the same thing for the standing bricks. First I will rename the mesh data to standing brick so it becomes easy to find again before switching to the single face shape it should have. Now I want to add the child object that will hold the brick shape. It is important for the child to have the same location as the parent, so with the standing brick selected, move cursor to selected. Then add any mesh and switch the mesh data to standing brick. Finally rename it dupli standing. We now have the two parts needed, so just parent the brick to the standing section and activate the duplication. And now the standing bricks are working as well. With both the beginning and ending done, it is time to do the same thing for the falling section. Move to the first frame so all the bricks are visible. This is a bit more cumbersome than ideal, since all of these 7 bricks are their own objects. The duplication works by parenting, but a child can't have multiple parents, so we can't use the same brick as a child for all of them. Instead, we will have to add a standing brick object to each one of them. Now you might wonder why I didn't just make all of the bricks in the falling section into one single object, moving them around using bones and weights. This would indeed make this dupliface part easier, since we could just use the same object for all bricks. However, during my testing I found that the cycle's motion blur is less reliable when that method is used, creating artifacts and problems. The bricks will look much better rendered if they are all individual objects, so that is why I chose to do it like this, even though it makes this section a bit more cluttered. So, let's first change the mesh of the falling bricks to a single face. I will select the first brick and change the mesh data to single face. We already have a standing brick shape saved, so we can discard the old mesh data. To add the same single face shape to all of them, I can simply link the object data. Let's also activate the duplication faces for all 7 of them so it is done. Now we need to add one child brick for each of them. Let's start with the first brick. Remember that it is important for the object to have the same location as their parent. The first brick is placed right in the center, so I will simply move the cursor to the center. Then add any mesh and change the object data to standing brick. Name it dupli_falling.000. Link duplicated 6 times, placing them 1 unit from each other, giving them the same location as the falling bricks. With the bricks done, all that is left to do is to parent them to the falling bricks above. Since we have already activated the duplication, the brick starts appearing as soon as we parent them. And now every brick has been replaced by duplifaces. Ignoring what is happening below the curve, it all looks like before, except that the bricks will keep their shape at all times. Great. All that is left to do now is to add an ending animation. So, how are we going to create that one? Although there are ways it could be done by using the bricks we already have, it would be very difficult and time consuming, and we would have to change our rotation drivers and the way it works quite substantially. So instead, I will simply add a different set of bricks for the ending. Whenever our bricks reaches the end, it will switch to a second set, whose only purpose is to end the animation. So I will add 6 new bricks used for the ending. To not make things too cluttered, I will do this work on a new layer, the 3rd, so I don't have to see all the old bricks. I want the armature and the curve to be available when I work on the ending, so activate them on the 3rd layer as well before we go there. I want to move to a new layer in the armature as well, so switch to the second bone layer, hiding the old bones. Now we are ready to get started. Add a new bone to the armature and name it ending.000. Go to pose mode and change the rotation mode to the less complex XYZ Euler. We want the bone to point downwards, but we also don't want it to overlap with the bones of the falling section. So instead of moving the tail to -1, I will move it to -0.7. Let's also make the bone a bit thicker so it will clearly stand out. Duplicate it 5 times, placing them 1 unit from each other for a total of 6 of them. These bones will control the ending bricks. Unlike the falling bricks, they won't move around, so we don't need 7 of them to handle the motion blur. To be able to move the entire ending at once, add another bone that will control them all. Name it Ending Master and parent all ending bones to it. Now it is time to add the actual brick locations, so go back to object mode. First add any mesh and rename it endingbrick.000. Change it to use the single face mesh. Add a curve modifier to it so it sticks to the curve. And activate the duplifaces so it is done. Link duplicate it 5 times so we get 6 of them. And parent them to the bones below. And now we can rotate them by rotating the bones. Now we just need to add bricks to these single faces. Add any mesh, name it dupli-ending.000, and set it to use the standing brick mesh. Link duplicate it 5 times so we get 6 of them, and then parent them to the single faces above. Since we have already activated the duplication, the bricks appear as we parent them. And now I can rotate the ending bricks by rotating the new bones. Great! We now have the bricks we need for the ending animation, so let's move them to the correct location, the end of the line. Add a driver to the X location of the ending master and add the length as a property. Since the ending section is 6 bricks long, we need to place it 6 units from the actual end, so set the expression to length -6. And now they are at the end of the line. These bricks should not be visible at all times. They should remain invisible until it is time for the ending animation, so add a mask modifier to the first brick and add a driver to the toggle. The moment they should appear depends on the current time and the length of the line, so add those two as variables. When the current time reaches the length, it has reached the end and the ending animation should start, so set the expression to time minus length. The switch between visible and not happens at a value of 1, so move the curve 1 unit up so it gets a value of 1 on frame 0. And now the brick appears exactly when it should, on frame 260, since we have 26 bricks in the line and a speed of 0.1, making each brick take 10 frames. Add the mask modifier to the rest of the bricks by linking, and remember to copy and paste the toggle driver as well. And now all the bricks appear at the same time, on frame 260. We want to add the opposite mask to the falling bricks, making them hide as the ending bricks appear. To do this, we need to stop focus on the ending bricks for a while and go back to the first and second layer. Let's also go back to the first bone layer. Let's start with the first brick. Now, these falling bricks already have a mask modifier. We could add another one to them that we use just to hide them at the end, but let's try to add it to the mask modifier they already have. We want the driver to work exactly like now, except for when it reaches the end, where we want it to be hidden forever. So, we want one thing if it hasn't reached the end, and another thing if it has. This can be achieved by using an if statement. An if statement checks if something is true. If it is, it does one thing. If it isn't, it does another thing. First of all, we need to change from averaged value to scripted expression so we can add more things to the driver. Change the name of the current time variable to time and set the expression to time so we get the same functionality as before. Since this will be dependent on the length of the line, add it as a variable. This time part is the value I want the driver to have before it has reached the end, so encapsulate it in brackets for clarity. Then I will write if bracket time is less than length ending bracket. This checks if it has yet to reach the end. If it has, this time part becomes the entire expression, making it work like before. We need to add another part telling what to do if it has reached the end. Write else bracket. So what do we want to happen? We want it to be hidden. And what value will make the brick hidden? Well, just look at the curve. The brick is hidden when the driver has a value of 6, so set it to just 6, and end it with a bracket. And now we are checking if we have yet to reach the end. If we still haven't reached it, the driver value becomes time, making it move along the curve like before. If we have reached it, the driver value becomes 6, hiding the brick. And now you can see that the brick disappears when it reaches the end at frame 260. Let's replace all the old mask drivers with this new one. Copy and paste it to the rest of the falling bricks. Remember to offset the curve by 1 for each brick, like we did before. You also need to increase the 6 in the expression by 1 for each brick since we moved the curve, making the mask turn off at a different value. 2, 3, 4, 5, and 6. And now the entire falling section disappears on frame 260. If we activate the third layer as well, we can see how it instantly switches from the falling bricks to the ending bricks. Great! Now we just need to give the ending bricks a falling motion. Just like with the falling section, we will do this by driving the rotation of their bones. Activate the second bone layer so we can see them. Let's start with the first ending bone by adding a driver to its Z rotation. I want the ending animation to be 2 units long, so move the second keyframe 1 unit to the right, to frame 2. Then set the extrapolation mode to constant so the curve doesn't continue to change. We now have a motion, going from 0 to 2. To make this motion start on the right frame, add the length and current time as variables, and then set the expression to time minus length. And now the brick starts to rotate on frame 260 and does so until frame 280. These are the only parts of the driver that will be common between these ending bricks, so copy the driver and paste it to the rest of the ending bones. And now all bricks rotate at the end. Currently, the switch between the falling bricks and the ending bricks is very visible. This is because the bricks goes from leaning to standing straight up. To make the switch seamless, we need the ending bricks to start with the same angle as the falling bricks end with. This can easily be done by simply copying the rotation value the driver creates for the falling bones and paste it to the ending brick. Let's start with the first brick. Make sure you are on frame 260, the first frame of the ending bricks, before you copy the rotation value from the first falling brick. Then go to the ending brick. It is the first keyframe that decides the angle in the start, so select it and paste the rotation in the value field. And now the switch between the two becomes seamless. Let's repeat this for every brick. Copy the rotation value from a falling brick and set it as the value of the first keyframe for the corresponding ending brick. And now the transition to the ending bricks is completely seamless. All we have to do now is to adjust the curves to get a nice falling animation. Let's start by giving the bricks a good final pose. This is done by changing the value of the second and last keyframe. To be able to see the changes we make, go to frame 280. This is where the bricks should have settled on the ground. The angle of every brick will be dependent on the last brick, so start by adjusting that one. It should be lying flat on the ground, so set the value of the second keyframe to 90. Then go to the next brick and adjust it so it leans on the brick after by moving the last keyframe along Y. Repeat this adjusting of the second keyframe for all the other bricks, going from right to left until they all lean on each other. Now we have the beginning and end of the falling animation, so now it is just a matter of adding more keyframes and adjusting the curves so we get something that looks good. The last brick is already working like we want, falling straight to the ground, so I will leave it as is. Moving on to the next to last brick, I want to add an additional keyframe on frame 1 right between the two we have. Make sure you are on frame 270 so we can see the result of the new keyframe, and adjust it so the brick is leaning on the brick after. Do the same thing for the other bricks, going from right to left. Add a keyframe on frame 1 by duplicating and adjust it so it leans on the brick after. To add the final precision to the animation so the bricks really make contact in the end, we can adjust the curve shape instead of adding more keyframes. And now we have a working ending animation. Great! Now the line of Domino is fully functioning, so all that is left to do is to make some small adjustments. One issue we currently have is the behavior of the first brick. Notice how it rotates too far, and as a result, on frame 60 snaps into place when it is replaced by the falling section. This happens because the brick is right at the beginning of the curve. To make the curve modifier affect the mesh more reliably, the mesh needs to be clearly inside of the curve. We can fix this by just moving every brick one unit along the curve, making the first brick start inside. Start by moving the fallen bricks one unit along X in object mode. As you can see, the dupli object is moved with it, since it is a child. Then select the falling motion armature and move it one unit in object mode as well. For the standing bricks, we need to change the location driver so it is moved one step further. This can be done by simply removing the -1 from the expression. Moving the entire domino 1 unit along the curve made the end go outside instead. We could increase the length of the curve to make it fit, but I will simply decrease the number of bricks by 2. Move the properties panel to the top so it is easier to reach, and change the count to 24. And now every brick is clearly inside the curve, making each brick behave perfectly. Let's turn off the curve shape key to see how the line looks in its original position. As you can see, things gets pretty cluttered with a lot of overlapping objects. This is because of all the duplicate objects still being visible in the viewport. We can't hide them since that would hide the duplication as well. They won't be visible when we render, but they can still be annoying since they clutter up the viewport. A way to effectively get rid of them would be to move them to another part of your scene where they are not in the way. However, currently there is no simple way of moving all the objects the domino consists of. To be able to do that, we will need to give everything a common parent. Add a sphere empty, and rename it Domino Master. It is a bit big, so change the displayed size to 0.5. Then select all the other objects without a parent in the outliner, and parent them to the empty. And now I can move everything, including the duplicate objects, by moving the master empty. So how does this help? I only want to move the duplicate objects out of the way, not the entire domino. Well, the great thing is that you can place the actual line of domino very easily by modifying the curve in edit mode. So to place everything we don't want to see somewhere else, we can move the entire domino by moving the master and then place the curve where we want the actual domino to be. For example, let's try to hide all the duplicate objects below ground. First add a plane, name it ground, and scale it up. We start by moving the domino master 3 units down so everything is below the ground plane. Then we can move the curve 3 units up in edit mode or by activating the shape key we already have, placing it right on the ground again where we want it to be. Doing like this, we can give one location to the duplicate bricks so they're not in the way, and one location to the bricks that will actually be rendered. Let's continue trying to clean up the workspace by hiding the armature and the time empty. Having a separate object for keeping the current time is actually not necessary anymore, since we have an armature it could be added to, but moving the property is more trouble than it is worth, so I chose to hide it. Since the domino now has 7 bricks visible in the beginning, the shortest length it can have is 7 instead of 6 like before. If we wanted to, we could have made the 7th brick hide in the beginning, keeping the minimum at 6, but instead I will just increase it from 6 to 7 in the length property. With that done, all that is left to do is to turn off the viewport selection for everything except the domino master and the curve. The user should not change anything else. This is easiest to do by expanding everything in the outliner 3 times using the numpad, scrolling past the parts we are not interested in, and simply dragging over all the available selection toggles except for the master empty and the curve. Collapse it all again using the numpad. And that's it! This concludes the tutorial on creating an advanced line of domino. I hope you have learned something. Thanks for watching.